June24, a tuning fork vibrates at a frequency of 512 Hz. When struck with a rubber hammer, the sound produced by the tuning fork will travel through the air as which? So let's draw a little picture of what's going on. We have a speaker, and it's not going to be very good, but this is my speaker. So sound is coming out of this thing. And how does sound travel? Does sound travel the way, there's a lot of examples that you guys do with a rope, where you take a rope and you lift it up and pull it down really quick, and it sends this pulse through the line, and this travels over to the end of the rope, and then if you keep doing that over and over again, you create this kind of sinusoidal effect. Is that how sound travels? No, sound travels differently. This is called a transverse wave. What happens in transverse waves, like the rope example, is that these pulses being sent through the rope are vertical. They go up and down as the wave moves to the right. So the direction of travel of the points on the rope are moving perpendicular to the direction that the wave's actually moving. So whenever we think transverse, we think perpendicular. Perpendicular. The other type of wave is what sound is, and sound is longitudinal waves. So what happens is when the speaker puts out a pulse, right, when it makes a sound, it pushes all of the air molecules together in that instant, right? So they're really densely packed along this wave front. And then after that wave front, they're kind of sparse. There's just a few of them. And then if it's, making a beat evenly with a certain frequency, which it does, as this has a consistent frequency of 512, then there'll be another wave front here. And then they'll be kind of sparse again, and then there'll be another wave front here, and another wave front here. And basically these molecules are moving back and forth, left to right. Right? It's a wave front here and a wave front here. And it's dense, 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 and then the spaces in between are sparse. So the actual motion of the air molecules that are vibrating is back and forth like this. And that's parallel to the direction of the wave itself, which is moving to the right away from the speaker. The direction of the wave is like this. That's the wave direction. So the direction of the air molecules is parallel to the direction of the wave. And that is an example of a longitudinal wave. So just remember this. Sound is always longitudinal. And try to remember this example. And that means that the direction of the air molecules is parallel to the direction of the wave. So the best choice is 1.